By the end of this video, you'll have learned to develop an application where 3 LLM agents, a host, a supporter, and a critic, debate on any topic of your choice. We'll also create a sleek user interface to showcase their discussion. Hi everyone, I'm Mohammed, and today we'll be developing an agentic application in which 3 LLM agents, a host, a supporter, and a critic will engage in a lively debate on any topic of our choice. We'll also create a sleek user interface to showcase our project. So, over the course of the video, I'll guide you through each and every subtle step of developing an agentic application from the backend to the frontend. And I will not just walk you through a pre-written code in which I've done the details before recording the video, and you'll not see them. And once you're trying to do it yourself, you'll face tons of errors and maybe you don't know how to fix all of them. I'll show you each and every step. We'll see how to deal with errors, how to consult the documentation, and how to find our questions inside the documentation. So if you're really trying to learn to develop an agentic project, let's do it together. Okay, so we'll be developing this project in 2 parts. Initially, we will develop the backend side, and afterwards, after we have a completely working backend, we'll start developing the front-end side. And for the backend, we'll be using the most recent version of Autogen, which is 0.5. And for the front-end, we'll be using Streamlit to be able to quickly develop a web application that visualizes the chats between the agents. So let's take a look at the Autogen's documentation. Autogen documentation. It was about a week ago that Autogen released its most recent version, version 0.5.1, which is a stable version. And, well, Autogen is a whole framework under which there are some sub-frameworks. And we have a core framework. This core framework is the low-level version, which handles the operations needed for dealing with LLMs and, the messages and some of the low-level operations. And then we have the agent chat framework, which is built on top of the core, and it facilitates the development of agentic projects. You can see the codes are pretty readable and straightforward. It has a good documentation, I can say. It has both a tutorial and a section for more advanced topics. And, we have some concepts. You should try to master these concepts. The models, the messages, the agents, teams, human in the loop, termination, and managing state. And today in this project, we'll be working with the models, the messages, the agents, the teams, and the termination. And we will leave the human in the loop and managing state to the next videos. So one of the main topics in Autogen is the agents, one of the main concepts. And we have an assistant agent. This class represents an LLM agent. It can also use tools if you want to do that. And as you see, it's pretty straightforward to define an assistant agent. We will specify some name. We should give it a model client, which is basically the underlying LLM. We can optionally grant it an access to some tools. And we can also specify the system message, which specifies the role of that agent. And to be able to define an agent, as you see, we need to define a model, an underlying LLM. And to define a model, we have this models concept. There are some classes for famous models, such as OpenAI, Ollama, and Gemini. So you can easily define an OpenAI LLM here. You see, you just need to import this class, OpenAI Chat Completion Client. And then you just need to define that LLM in one line and in one statement, and then you're good to go. Okay, so let's do that. From Autogen extension.models.openai, import OpenAI Chat Completion Client. And now I can easily define a model, a chat completion client, and the model will be GPT-4o. And I need to declare my API key. So as usual, you have two options. first of all, please don't copy and paste your API key here. You can either have it in a separate file, and you should make sure that file isn't pushed to your GitHub repo and isn't public, or you can specify and you can define a system variable. So I can say for the API key, open API.text, read it and make sure there's no extra space in the end. So now I've defined my LLM, and to be able to work with this LLM, to be able to send it a prompt and get the result, I can use the create method. So this model has a create method. As the documentation suggests, it gets a messages, which is a sequence of LLM message. So I can easily say messages equals, well, it expects a sequence, so I can pass it a list. And well, one particular class for messages in Autogen is the user message class. So as you can see in the documentation here, we can define a user message. We can import it from Autogen core.models, and let's take a look at, let's import it from Autogen core.models. Was it models? Yeah, import user message. And now I can define a user message. And as suggested by the documentation, it gets a content and source. So I would say content is, hi, how are you? And I should also define the source of this message. So I would say, that should be here. I would say source is user. And well, in the most recent version of Autogen, there has been a huge focus on the async workflow. So, we can do programming usually in two different modes, in two practices. One of them is the synchronous mode, and the other one is the async mode. So if you're not familiar with those concepts, don't worry. I'm sure after this video, you have a good intuition. And of course, nothing stops you from going and searching and reading some tutorials about them. But to just roughly talk about it, we have a synchronous way of programming. And in synchronous way, each line is executed, and we will wait until that line is completely done. And after it's done, we will move to the next line. So this is, very roughly speaking, this is the synchronous way. And then we have an asynchronous way. For projects that have natural I/O bound, the program should wait for some outsider source to respond. So our project doesn't need to do a lot of processing, but should wait a lot. In these cases, and in more sophisticated projects, while waiting for example, the agent to respond from the OpenAI server, we can do other tasks that are not directly relevant and directly dependent on the current agent. So this helps us save a lot of time instead of waiting idle. So this is why, in most of the agentic projects, it's a very good idea to develop it with async mode. So we should import the async.io module from Python. And again, if you're not familiar with this library, don't worry about it. You will learn how to work to the extent that the agents can be functional. So for coroutines and for functions in async mode, instead of calling them like this, we should await them. And we should also define an event loop. And by an event loop, we'll see what I mean. So first of all, let's define a coroutine. A coroutine is a function in the async mode. So I would say async def main, and it has all these codes. And then here I will define the coroutine. So asyncio.run main. This means that I've created an event loop, and in the event loop, I'm running this coroutine. Okay, so now I'm awaiting model.create. So this means that I can send some prompt to the LLM to model, and I will get the response afterwards. And as the documentation suggests, it returns a create result object. We can also take a look at the create result object, but we can just print it now to see what it is. So this is the result, and I can just say print res Python debate. Okay, let's see. So as we can see here, the res or the create result object is a data class. It's in Pydantic way, or a data class in Python. It's a custom class to store some data, a structured way to store some data. We can get the finished response, the finished reason, the content of the result, and also how many tokens it was, and was it cached or not. And if we've asked for it, we can also get the log prop for each token. So if I want to print it more clearly, I can just say print res.content, and in this case we'll just see the response from the LLM. Hello, I'm just a program, so I don't have feelings, fair enough, but I'm here and ready to help. Okay, but we don't need to directly interact with the model. The agent will do that for us. So now we can define the agents, and for the agents I need to import the AssistantAgent class. So from Autogen agent-chat.agents import AssistantAgent. Now I need to define a supporter agent and the critic agent. So let's define the supporter. I would say supporter is an assistant agent. It should have a name. The name will be John, for example. And here's the system message. You are John, a supporter agent in a debate for the topic. And let's introduce topic as a variable so that we can easily change the topic later. And the topic will be, let's say, shall US government ban TikTok? And this will be our topic. You will be debating against, let's say, Jack, a critic agent. This is good enough, and let's clear this. And I should also specify the underlying model. So we have a model client, which is just the GPT-4o model I introduced earlier. And this will be the supporter agent. Now I will define the critic agent. And usually when I just want to mirror something else, and with some subtle changes, GitHub Copilot can suggest a clean piece of code, as you can see here. The name is Jack. Here's a system message. You are Jack, a critic agent in a debate for the topic. You will be debating against John, a supporter agent. And this will be the model client. So now I have the supporter and the critic agents, and it's time to create a team out of these two agents. So let's take a look at the team section of the documentation. By the way, this is a very good skill to be able to read documentation. If you have any questions from a module, it will be a very good skill to be able to read the documentation and find the answer for your question. So this really makes the difference between a professional programmer, a professional developer, and a so-so developer. So for the teams part, we have three options. We can have a round-robin group chat, we can have a selector group chat, or a magnetic one group chat. So today we'll be working with a round-robin. Let me just briefly talk about each of them. Round-robin group chat, as the documentation suggests, it's a team that runs a group chat with participants taking turns in a round-robin fashion. This means that we have a deterministic chat, and we know in advance that which agent is going to talk when. So if we have two agents, a team of two agents, the first one talks first, then the second one, then the first one, then the second one, and the conversation goes on and on until we have until a condition is met and we terminate the chat or the maximum number of turns is reached. But the other two options, the selector group chat and the magnetic one group chat, these two are not deterministic. They're non-deterministic chat patterns. So we don't know in advance which agent is going to talk when. It depends on the context. It depends how the chat goes on. So we'll be working with the round robin today, since we just have two agents and they're going to talk in a round robin fashion. And this is the documentation for the round robin group chat. We should import it from Autogen agent chat.teams. And as you see, it takes a participant and a termination condition possibly, and maximum number of turns in the group chat before stopping. Okay, so let me import it. I would say from Autogen agent chat.teams import the round robin group chat. And let me introduce the team. It will be a round robin group chat, and it will have the following participants: a supporter and a critic. And for now, I will just specify the maximum number of turns, let's say 4, and that's it. Okay. Now I need to make the team start the conversation, start the debate. And for that matter, we have a run method. So I can say await team.run, and I should specify a task. So that will be, and what is this task? It will be, well, the documentation isn't that clear here, the task to run the team with. This will be actually the initial message that will be broadcast to the team. So I would say start the debate, for example, and it will return a task result, as you can see here. And just like the create result, a task result is another custom data class, and we can get the whole conversation once the team returns the task result. So I would say res equals await team.run, and then I would say let's print res Python debate. And now you'll see it will take a significant amount of time until we see the result. And this is a disadvantage of working with the run function. So while we're waiting, I encourage you to think about it. How can we mitigate this problem? How can we address this? Okay. Now you can see we have the whole chat. This is a task result object. It has a messages component and the messages is a list of text messages. For each text message, we have the source and we have the content. So for example, this is the user's message, start the debate. And then we have John, the supporter, and thank you for the introduction. As a supporter of not banning TikTok in the United States, I believe it's crucial to emphasize the potential consequences and underlying issues and so on and so forth. And we have, dialogues from Jack and then from John, and then we've stopped the conversation. And this is a stop reason, maximum number of turns 4 reached. So I can print out the chat more clearly, and I can have a for loop for message in res.messages, and then I will say print. Initially I will print a bunch of dashes to make sure each dialogue is separated from its surrounding, and then I would say print message dot. You can see Copilot hallucinates in these contexts because these modules like Autogen are pretty new and it hasn't been trained on these modules. So it tries to figure out by itself, and it almost always hallucinates in these situations. So just say, please never trust Copilot, and never just blindly accept what it is suggesting. So I want to print out the message dot source, and then a colon, and then message dot content. Yeah, this is right. Content. So let's run the code again. Now we should see a much more clear version. Okay, you can see here's the user message, here's John, here's Jack, again John, and then Jack. So we have a quite functioning backend side now. So the script works and the agents are engaging in the debate. But one particular problem now is that we should wait until the whole chat is done, the whole debate is over, and then we will print it out. So we would like it to work this way, that we can gradually print each dialogue once we have it, once it is ready. So to do this, the team has another method. It is called runStream, but it works quite different from the run method. So let me show you the runStream. We can say team.runStream, and indeed, runStream is a generator. It's an async generator, as you see here. And if you don't know what is a generator, don't worry about it. I will talk about it momentarily. But I strongly encourage you to go after this video and read a little bit about generators. It's a very useful concept in programming. So generator is essentially a function, but instead of returning something, it yields something. And what is the difference? So in a regular function, whenever you call the function, it starts from the beginning of that function, from the initial line, and it goes on and goes on until it reaches a return statement, and then it returns something, and then everything is reset. So the next time you call that function, it will start over again, and it will, run each line until it sees a return statement. But a generator is a function that has some sort of memory. So whenever you call it for the first time, it starts from the beginning. It goes on and goes on until it sees a yield statement. So it returns or yields that whatever is after yield, but it doesn't reset. It stays there. So the next time you call that generator again, it doesn't start all over from the beginning. It starts from where it left off. So it starts from the last yield statement and then goes on and on until it sees another yield statement. So as you see in this concept, a generator can be quite helpful, because once we have a response from an agent, we can yield it and we can stay there, and then we call it again and we have the response from the next agent, and then we call it again and then we have the response from the next agent. So this is how the generator idea can help us. So this is a generator, so we can call it several times, or we can even iterate over it. And since we're developing this part in async mode, we should you should use async for message in team.runStream. And this generator can return two types of objects. While the agents are working, it will return some messages, as we saw earlier here. It will return some text messages. This is its return type. But once all of the agents are done and the chat is over, the debate is over, it will return a task result object. So I should handle these two types of objects differently. I can say if message is an instance of task result, so if is instance message and task result, and I should also import the task result. So let me check where's the task result. You see we're in the RoundRobinGroupChat, and RoundRobin is a child of BaseGroupChat, and inside BaseGroupChat I can see the common methods. One of them is run and the other one is runStream, as we can see here. And inside runStream I can see it says that the return type is task result, and here it is. A task result is inside Autogen agent chat.base. Okay, So from Autogen agent chat dot base import task result. So if message is an instance of task result, I just want to print out the reason for stopping the debate. So print stopping reason and message dot stopping reason. I guess it should be stop reason, not stopping. Let me check. Yeah, stop reason. So otherwise, I know that message will be a text message object, so I will just print the source and the content. And again, to make sure different messages are separated, I will have some dashes. And let me remove this part. Okay, let's run it again. Now I should gradually see the agent chats. You see, we're seeing user. Now we've seen John's response and now Jack's response. So instead of seeing all of the chat once the debate is over, now we can see, as the chat is in progress, the debate is progress, we can see the agent's results, the agent responses. And stopping reason now is that maximum number of turns, which is 4, has been reached. And to make it more natural, maybe it's a good idea to also introduce a host for the debate. So let me define a host. It will be another assistant agent. The name will be, let's say, Jane. Yeah, Jack, John, Jane. And I need to define its model client. It will be the model again. And this will be the system message. You are Jane, the host of a debate between a supporter agent, between John, a supporter agent, and Jack, a critic agent. You will moderate the debate. And then at the beginning of each round, so here's what I want. I want the host, I want Jane, to declare which round this is at the beginning of each round. And after maybe the third round, I want her to declare that the next round will be the final round, and then to terminate the conversation, the debate. So at the beginning of each round, announce the round number, and at the beginning of the third round, declare that it will be the last round or the final round. After the last round, thank the audience and exactly say terminate. Okay, so this is the system message for the host, and now I should also add the host to the team. Since I want the host to start the debate, I will add it here. So we have a host, we have a supporter, and we have a critic. And now let's specify some large number, maybe 20. So I can run the code and you can see the result. Of course, it will not terminate the chat after the fourth round. We'll see why, but it's a good idea to take a look at the debate now. Okay, now we can see Jane's dialogue. Welcome to the debate, everyone. Let's begin with round 1. John and Jack, are you ready? Let's dive into the topic at hand. The impact of technology on society. Oh, we forgot to pass the topic to the host. That's why it is hallucinating. So you are Jane, the host of a debate between John, a supporter agent, and a critic. You will moderate the debate, and then I would say the topic of the debate is topic. Yeah, this is right. Okay, now let's see Welcome everyone to this engaging debate on the topic, shall the US government ban TikTok? Okay. And then we have John, which is supporting the idea, and we have Jack, which is a critic of the idea. And yeah, thank you, Jack. Now we enter round 3, which will be the last round. John, please proceed with your final remarks. And then we have John's comments, and then we have Jack's comments. And in the end, you see Jane has thanked the audiences, the participants, and we have terminate here, but the debate goes on and on. And that's because we haven't specified in our code to what condition will terminate the debate. So we need to do that as well. In the previous version of Autogen, in version 0.2, we should have specified the termination condition for each agent, and we would have passed a callable function, a callable object, a function, or a lambda function. But in the new version, in 0.5 version, we should do that with the team. So I can say what is the termination condition. And for termination condition, we have a bunch of options. Let me show you. If you go to the termination page, so we have a lot of possible termination objects. You can see a termination condition, and that termination condition can be any of these conditions. For example, it can be an external termination. It can be a function call. So whenever a function is called, then the chat will be terminated. Or it can be for a text mention or a text message termination. So we'll be working with the text mention termination today. This means that whenever a specific expression or word is mentioned, it will terminate the chat. Or even whenever we have a text message, it will terminate the chat. But well, we just need to be vigilant for the terminate term. So we'll be using text mention termination. And we can import it from Autogen agent chat.conditions. Let's import it from Autogen agent chat.conditions, import text mention termination. Okay. So the termination condition for the team will be a text mention termination object with the following text, which will be terminate. So from now on, whenever I have capital terminate in my chat, it will terminate the whole team and the whole chat. Let's run it again. Okay. Yeah, we can see that once Jane has declared terminate, the chat has been terminated. And here's the stopping reason: text terminate mentioned. Fair enough. And by the way, the chat is so interesting. You can read it and enjoy it. We can see convincing reasons from both sides, but you can run this code for yourself and read their reasoning. It's quite interesting, and I will definitely create some short videos from these debates. I guess it really worth it. Okay, so now we're done with the backend side. We have a fully functional backend. We're orchestrating the team, and we have an interesting debate between these two agents and our host. So now it's time to develop the UI and the front-end side. We'll be using Streamlit, and by the way, Streamlit has some visually appealing components, and it is usually used to quickly develop a prototype or a web application. So let me create an app.py. we can import Streamlit as st. Initially, we should set a title for our web application. The title will be Debate App, Agents Debate, or let's say Agents Debate. It's more interesting. And let's run it right now to see what we get. And to run an Streamlit app, you cannot say Python app.py. You should say Streamlit run app.py. Yeah, we have a quite empty page now with just the title. Let's go back. Now we need a text input to get the title. The topic of the debate. I can say topic will be st.text input. Enter the topic of the debate. And I can specify a default value for the topic. Shall US government ban TikTok? Yeah, this is good. So let's see what we have now. Yeah. Enter the topic of the debate. Shall US government ban TikTok? Good. And I need a button below the topic text input. So, and I want to see if the button has been clicked on or not. So I will use the clicked variable, and I will say st button, and the button label should be start. I can also specify a type for the button. It can be either primary, secondary, or other values. So let's say primary. This will make it prettier, at least to my eyes. And if the button is clicked, then I should orchestrate the team, the agents, and the debate should start. But for now, let's just, to see the logic, I want to just write debate start. So you see, this is the title, this is the topic, and once I click, it says debate start. Well, I should modify the debate a little bit so that I can use it inside my UI more effectively and more easily. So right now we have all of the backend code in one coroutine in main. And by the way, we have the topic as a variable here, but we're not, passing it to the main. It's hard-coded inside the main. So I want to split these into two coroutines. In the first coroutine, I will configure the team. And in the second coroutine, once I've configured it using the first one, I will orchestrate the team. And I will, make that coroutine to be an async generator. So in our UI, we can call it, we can iterate over it. And once we have a new message, we will display it as a chat. Okay, so I need to split this into two coroutines. Let me define a new one, async def team config, and it should get a topic. I just need to move all of these lines until the team definition inside the team config. You see? And of course, I don't need to specify topic here anymore. I can easily specify topic inside this part. So now I have a team config, and then I will rename this as debate. And in the debate, again, I need to get a topic, and I need to, let's pass the team to the debate. And once I have the team, then everything looks good for now. And then I will define my main coroutine. I'm just defining this one so that, this debate.py could be functional alone without needing to depend on the app.py. So here I would say topic will be this one. Team will be await team config with this topic, and then await debate team. Okay, this looks good, but I want it to work quite different. I want to turn this debate into an async generator. So for that purpose, I can, instead of printing this here, I can just say, I can define a message variable. So this will be, instead of printing it, I will say this is my message, and then I will yield the message. I will do the same for the else statement. Message will be this one, and I will yield the message. And now inside main, here's how I will make this debate work. I will iterate over this generator. I would say async for message in debate with this team, and print message. And I don't need to specify this, just print message. And I will print some dashes again to make sure dialogues are separated. So now the debate function, the debate script should be fine. It should work. Okay. Non-type object has no attribute run stream. Okay, it doesn't know the team. So I have the team here. Yeah. Inside this team config coroutine, I forgot to return the team. That's why it is none. Yeah, it's working now. Okay, now the only thing I need to do inside the app is to import these two coroutines from debate, import team config and debate. And now inside this if statement, if the button is clicked, I need to create the team. But since my backend is working in the async mode, I need to create an event loop here again. So I will define a coroutine here, async def main, just like my debate.py. And I would say team will be configure team with topic, and then I will iterate over the debates generator. And instead of, okay, I should show this to you before using it. Maybe it's a better idea. Streamlit has some elements for chat visualization. One of them is chat message. You can take a look here, st.chatMessage. It takes a name and an avatar, which could be an emoji or an image or a pre-specified name like user or assistant or AI. And it will visualize each dialogue from an agent. So I need to define a container here, and initially it will be empty. So I will say, for example, chat will be st.container. And whenever the button is clicked, first of all, I will make sure that chat is clear, chat is empty. That way I can, have several debates in my app in one run of the app. I don't need to close the app and run it again for the next debate. And then I would say with chat, I want to do it inside chat. And then, let's move it here. Inside the chat container, I will iterate over the messages from the agents. And I would say we have three modes. We have three possible options. A message could be from Jane, it could be from John, or it could be from Jack. So I should handle them differently. So here I would say if message dot starts with Jane, for example, because you see in my message template, I always have the name of the agent at the beginning. You see message.source. So if message.starts with Jane, then with sc.chat message with the name of Jane and the avatar of, for the avatar, I will use a robot emoji, yeah, as suggested here. Then just write down the message, sc.write message, and then elif message.starts with John, then with the chat message with the name of John, and I will use an avatar of thumbs up. You can either search for this avatar, or I have another trick. I will make this in the comment so that Copilot can suggest it to me. Thumbs up emoji. And now I expect Copilot to, yeah, it's suggested. And then I'm sure Copilot will figure this out. For Jack, it will use a thumbs down, yeah. So we have a thumb down here. And I guess we're good to go. Let's run the code. Oh, and I need to create the event loop now. So let's import the asyncio. And here I will say asyncio.run the main coroutine. Okay, let's run the Streamlit app and see what happens. Oh, we have an error. Oh, what is this ent? Okay, let's run the code again. Okay, here's the application. Here's the topic. I will press start. And yeah, Jane is welcoming the audience. And we have John's dialogue. And then we have Jack's dialogue. And then we have Jane again. So you see it's working. Now we have a web application that visualizes the debate, the chat between the agents. And just for fun, I can do one more thing. I can also, in the end, once everything is okay, I can say sc.balloon. I guess it was written like this. Let's see. The balloon. Streamlit. Balloon. Yeah, st.balloons, it's right. So once the chat is over, I want to show some balloons coming down the screen. So this way I can figure it out that the chat is done, the debate is over. Yeah, yay. So we've developed the backend and the front end side of this debate between two LLM agents with the host. You saw how easy it was using both the Autogen and Streamlit. So I strongly encourage you to do this yourself. You can watch the video, but please, you need to develop it yourself from scratch without consulting the video. This is a really important skill to be able to start from scratch and do the coding. And once you have an error, that is really okay, but you should be able to address that error. You should be able to solve it. So I recommend, please go ahead and do this yourself. And by the way, if you have any idea for the next videos, other applications that can be done using agents, please feel free to comment it, and I will definitely record the interesting ones. So until the next time, take care.